Good. And then I need to remember to mute this tab, otherwise I end up hearing myself and I don't want to do that. There we go. So thank you very much for coming along to .NET Nuts, and that is you folks online at home, as well as the folks that are here. So yeah, thanks for that. This is .NET Nuts, and we are, oh, look at that, we need to select the right screen if you're going to use that pointer. We're running a nice meetup, shall we say. We've got a code of conduct in place. There's a fair amount of words on that screen, but really it boils down to the bottom one: be kind and considerate to others, and we'll have a good event. If anybody feels as though they're being made to feel uncomfortable, either here or online, then send a direct message either to myself, and certainly if you're in person, then just come see me, or Connell if you're online, and field questions like that, and then we'll go through a protocol and make sure that you're made to feel comfortable. But touch wood, we've always run a really nice meetup, and everyone that comes is nice, so it always works well. So we've got some wonderful sponsors. BGSS, where us in-person speakers and attendees are sat around or stood up. I don't know if one of you wants to say what BGSS does, or if you're happy for people to just guess.
We do software.
Yeah, they do software. Yes. Yes, very good. Are you hiring, or is there a hiring freeze still at the moment?
We're always looking for the right talent.
Let's put it that way. So do get in touch if either a career change or yes, it's okay. Not anymore. Also, we're sponsored by the wonderful Rebel Recruiters. Do you want to say what Rebel do? Do you want to come stand here and tell these people at home as well? And I say I like putting people on the spot. It's fun. Yeah.
You're making it uncomfortable. Do you have to send you a DM now? Yes,
that's true. I've broken my own code of conduct. Yeah.
I've not spoken.
Hello,
everybody at .NET Nuts. Yeah, I'm from Rebel. We do recruitment-y stuff. I focus on .NET, hence why I'm here. I'm also local. Generally, we just focus on sort of tech recruitment, mostly in and around East Midlands. We try and be nice people too. So, hi everyone.
A really good fit for what we do here and what BGSS do as well, actually, and that culture is hugely important, the way they go about doing it. I've worked with Rebel with meetups for years now, might be 10 plus years, a long time. So thank you for that. So Rebel are sponsoring the drinks in the fridge and the pizza. Well, the soft drinks, the alcoholic drinks are sponsored by BGSS and where we're sitting, BGSS. And then my company, so I do all the hosting and organising and travelling around, so that's why that's there. And then JetBrains. So JetBrains make developer tools for developers. If you haven't heard of them, I'd be surprised. Things like ReSharper, WebStorm, PHPStorm, IntelliJ, things like that. And in fact, if you tweet on the hashtag .NETNuts, and I promise, because I've got a backlog of them, to give away some codes. In fact, they send you an email telling you that if you don't give away codes soon, we're going to stop giving you codes. So I need to do that. And then we can do that. So I've probably got like 4 codes I could give away. So if you do that tweeting, then there's a very good chance that you'll win a 12-month license to one of their products. And it's well worth it for that. And if you come along to enough of these, you probably never need to actually buy it again, personally, because there's a good chance of you winning. So do that. I'm an MVP, and I think the only one, Simon Pate, you an MVP?
I'm an MVP.
Yes. So, and this guy's an MVP as well. So if you want to find out a bit more about what that means, then by all means approach one of us. If you're here, then do that. If not, then just send me a DM or a tweet. But really, it's if you're doing community work or open source or anything like that in and around the Microsoft space, then a few thousand people in the world get rewarded with what's called the MVP status. And we get to work then with the program groups over at Microsoft, go and attend things fun like MVP Summit, and drive product with them, and also we get some free Azure credits, which is very useful. So yeah, well worth talking to one of us about that. So tonight we've got 2 speakers. These are the wrong way around for the running order, but we've got after Peter Bull, we've got Simon Painter talking about basic machine learning algorithms, and then Peter Bull will be taking a note of XAML with .NET 8, and we'll be starting with Peter next month. I'm not sure. I'm trying to persuade my friend Cliff to come up and talk about Maui. So if Maui is something that's interesting to folks, then hopefully I can persuade Cliff to come up. But he's also an airline pilot, and so getting his rota ahead of time can be difficult. And in September, all being well, we should have David Whitney talking about something. It doesn't matter what David Whitney talks about, it will be good. That will be that. We won't have anything in July and August because holidays and all of that. So that probably to you just as much, but
Yeah, next month's last Monday.
3rd of June. It is. So next month will be the 3rd of June as a point of note. Still a Monday, but yeah, bank holiday, and no one wants to do a meetup on a bank holiday. Well,
And then will there be an end?
probably, yes. That's a really good point, actually. Yeah. Yes, there will. And so I need a speaker for that as well. You know, if you're in the room or if you're online and you fancy speaking at .NET Knots, we do take speakers, any experience level as well. We're a really friendly group of people. We've had lightning talks recently as well, where folks were giving their first talk. So you're more than welcome. Send me a tweet or DM and we'll sort you out. And that's enough of me waffling on. Normally there'd be what we're doing next month, but as I've just said, I don't know. So keep your eye on the Twitters and all of that. So I will stop sharing. Oh, there we are. And I'm going to disconnect my machine and let Peter Bull take his spot. As far as Q&A is concerned, just type it in the chat if you're online, obviously. If you're here, then by all means, interrupt. I guess you're all right with that?
Yeah, I don't mind being interrupted.
Cool. We can go like that, but in the chat, it just tends to be a bit easier if you're online. So Connell can shout at me if there's anything really important. Do shout if you can't hear us or you can't see us or anything like that, important stuff. And with that, I'm going to disconnect my screen.
How do the online people see it?
Nothing much really. They'll see this moving around, making people ill. That would be about it, really. Should go to an advert or something. And I'll hand you over to Peter. So thank you very much.
One of the many windows you've got. Lost the Zoom window.
Yeah, it's very easy. So minimize it so out the taskbar. Or did you restart and it signed you out?
Oh, yeah. Oh, yeah.
Oh, there it is. Yeah.
Got it. Right.
Cancel.
Yeah, don't want to leave the meeting.
No, that would be silly. Good.
There we go. Excellent. Hopefully that's working.
See screen.
Brilliant.
And just shout if you can't hear Peter, but
Yeah, exactly. Tell me if you can't hear me. Right. Yeah, it's great to be here. Welcome. I'm Peter Bull, and this is my talk, Take Note of XAML with .NET 8. Sure this works. So, .NET is the free, modern, and unified open source cross-platform framework. That's a hard one to get out.
Can you just hit the OK button on that?
Yeah, of course. Sorry. Yeah. There we go. I'll go back so we can see that. Just getting. There we go. Perfect. Okay. So .NET is the free, modern, open source cross-platform framework from Microsoft. And that allows you to build apps and services for the cloud. You could build them for the web. You can build them for the desktop, which is what I'm going to focus on today. You can build them for mobile as well, gaming, IoT, and everyone's favorite current subject of the day, AI. So you can pretty much use .NET for anything. .NET 8 is the latest version of .NET that was released back in November 2023. .NET 8 is a long-term support release, so that's supported for 3 years until November 2026. You've got plenty of time to get started and get using it. And it has thousands of performance improvements across the entire stack, from code generation to just-in-time compilation. A lot of improvements there. Along with the .NET 8 was C# 12, and that's the latest version that was released, and it added some cool new features, including primary constructors. So you can basically initialize a class a bit more easily, allowing for simpler declaration or less typing. Is what the devs not like, typing too much, so that cuts that down a wee bit. Another thing it supports are collection expressions, which again saves a bit of typing. It means you can assign to collections using the square bracket syntax. So it's a lot nicer, a lot cleaner for common collection values. So what on earth is XAML? So XAML is Extensible Application Markup Language. It's an XML-based declarative markup language that can define objects that can have rotations, animations, or other effects applied to them. It can also have vector-based controls. You can scale a radio button or a checkbox for, say, the sphere in Las Vegas, for example, or just the desktop application. It doesn't need to be that big. You can also restyle controls as well, and there are templates as well, and lots of other things you can do as well. XAML basically allows developers to decouple the design of their user interface. So your application can look like anything you like. And then the implementation of that interface can be like any events or business objects and any other code. So you can basically have a nice design application, but have it all underneath with C# code. How does the interaction actually work? So basically you can have data binding that allows you to basically bind from a source value in that code in C# to a target property in XAML. And you can even convert values to present data to users as well. Or you can allow interaction from a user to the data in a backend as well. So XAML and .NET platforms, they include Windows Presentation Foundation, codenamed Avalon. It was first introduced in 2006, and it also introduced XAML as well, as part of the .NET Framework 3.0. It's still actually relevant today in modern .NET. It's still a major part of .NET 8. Windows App SDK, codenamed Project Reunion. This was first released in 2021, and that uses WinUI 3 with XAML, and that can leverage the power of .NET 8 for Windows applications. Finally, we've got .NET MAUI, or .NET Multi-Platform App UI, and that was first released in 2022, and that enables cross-platform development using XAML and .NET 8. There's also some alternative platforms as well that take advantage of XAML and .NET. They include Uno Platform. It's a free open source platform for building polished apps cross-platform for mobile, web, desktop, and even embedded apps, and even a web browser as well using WebAssembly. Avalonia is another open source UI framework that also allows you to create cross-platform applications for desktop, mobile, and browser. And it's based on Windows Presentation Foundation, so it allows you to modernize your WPF apps and bring them to the web. Then finally, there's OpenSilver, which is an open source plugin-free framework for resurrecting all those Silverlight applications. You happen to be a Silverlight dev, you can bring them back in the browser as well, where they belong. And that also allows you to build stuff because it's similar to Windows Presentation Foundation. So these are some options that allow you to reuse all that old stuff and bring it right up to date. There's also some toolkits to help us devs not have to write too much code as well. So these provide additional functionality. Here's an example of one, the CommenSys toolkit for .NET Standard. That's my own package, just giving it a wee plug there. So that's got some cross-platform functionality for data binding and a few other useful methods. A nice small toolkit, so it doesn't take up too much space in your projects. Then we've got this one, it's Modern WPF UI by Kinara, and that brings modern styles and controls from Windows 11 to Windows Presentation Foundation. So your WPF apps can fit in with Windows 11, although WPF is going to be updated soon to support modern looking controls natively soon. So you can use this in the meantime. Then there's the Windows Community Toolkit. That's basically a collection of common controls and services for applications using WinUI, such as Windows App SDK. Then finally, there's the .NET MAUI Community Toolkit. And that is basically a collection of functionality and things that tend to be repeated across .NET MAUI applications. So rather than write them again, you can use this community toolkit and integrate those into your application. So first, Windows Presentation Foundation. Let's talk about that. So Windows Presentation Foundation in Visual Studio, that allows developers to write XAML in the XAML view. So it's kind of like XML, so you just write it straight in there. Or there's a designer. So you can actually drag and drop controls like buttons and checkboxes and other controls straight onto the design view as well. So you can put your application together either way. So if you prefer markup, you can do it that way. If you want to use a designer, you can do it that way. What elements can it support? Many different media elements. You can support images, raster images, and videos, along with audio as well. And you can also display vector objects like shapes and lines using a variety of brushes, gradients, fills, all the kind of things that you want in an application. Windows Presentation Foundation also allows developers to build Blazor hybrid apps. So you can have a native Windows application with a reusable Blazor UI. So you can basically mix and match your web applications and your desktop applications with WPF. So Windows Presentation Foundation was the first platform to use XAML, but it allows .NET 8 developers to create a WPF application, and that can target from Windows 7 all the way to today's Windows 11. And all you need to do is install the .NET desktop development workload for Visual Studio 2022. The great pro of this is you can modernize those legacy WPF applications you've had lying around since 2006. You can bring them right up to date in 2024. The only con of WPF is it's got that reputation of being that kind of technology based in the mid 2000s rather than the mid 2020s. So there's a bit of a legacy reputation there, but it doesn't have to be. It can be. You can use it in modern .NET. If you want to find out more about using it, just go to github.com/.net/WPF. So what kind of things can you do? So here's an example of an application. This is called IDS CryScan, and this was developed using Windows Presentation Foundation in modern .NET. It basically is an application that allows a user to scan a QR code and load specific information for the IDS system, which is basically a pharmaceutical device. And I know this one uses WPF because I wrote it. So. Okay, next one, Windows App SDK. So Windows App SDK uses WinUI 3, and that is the native UI platform for modern controls and styles that embody the Microsoft's Fluent Design System. That's their modern design for controls and various elements you see in Windows 11 today. But you can only write in XAML with Windows App SDK. There's no design experience. But you can, while an application is running, take advantage of hot reload to tweak your application to get it looking just the way you want. Windows App SDK supports the latest APIs that are supported in Windows 11, and those implementations are decoupled from operating system releases, so they can be updated on a more regular basis. It also combines the APIs of its predecessor, Universal Windows Platform. So if any of you were a Universal Windows Platform developer, which I also was as well, you can use those APIs. It's also been converged with the Win32 APIs, so you can take advantage of both. So you can either use the modern APIs or the older Win32 APIs. Another thing you can use Windows App SDK for is you can create a widget provider. So you know the widgets bar in Windows 11, you can write an application that can interact with those, either to display information from your application or interact back from a widget to your application. And those are just created using adaptive cards, which is basically a JSON-based syntax for creating widgets. But yeah, you can use those in your Windows App SDK applications. So Windows App SDK, that's the successor to Universal Windows Platform. So if you're using UWP before, this is what you'll be using now. And it's available as the Microsoft.Windows App SDK NuGet package. There's a major release every 6 months, but there's also minor releases on a regular basis. The latest one is 1.5.2, and that was released just a few weeks ago. And those are released on a more regular basis with fixes and sometimes minor new features as well. The Windows App SDK combines Universal Windows Platform and Win32 and leverages WinUI 3 for the user interface, features those modern looking controls with Microsoft's Fluent Design System, And it has XAML that's very similar to Windows Presentation Foundation, so you can basically migrate across really easily. And you can basically target from basically for Windows App SDK, you can target either from Windows 10 1809, which is a very specific version of Windows 10, right up to the latest version of Windows 11. And all you need to do is install the .NET Desktop Development Workload along with the Windows App SDK C# templates. Don't think they're still ticked by default, so you need to tick that box to get them as well. So if you don't see Windows App SDK, which shows up as, confusingly enough, WinUI 3 in desktop, then you need to tick that box in the installer and then they'll appear for you. Great Pro Windows App SDK. You can write your apps that look just like the other apps on Windows 11. So you get great first-party looking applications with your third-party applications. One major con, no Blazor Hybrid, which is a real disappointment. That's one that I'm like, just add that. So it's a bit of that's the only thing that you can't really use with Windows App SDK at the moment. And if you want to find out more about Windows App SDK, you can just go to github.com/Microsoft/Windows App SDK. So, what kind of apps are available that use Windows App SDK? Well, Apple, interestingly enough, was assisted by Microsoft to produce apps that use WinUI 3 on Windows using Windows App SDK. So that includes the Apple Devices app, the Apple Music application, and the Apple TV application as well. So all of these are great Windows App SDK applications written by, not Microsoft, but there is a preview of the Microsoft Photos application, and that uses Windows App SDK as well. So when that's finally released, that'll be a fully fledged Windows App SDK application as well. So finally, let's talk about .NET MAUI. So .NET MAUI in Visual Studio doesn't have a design view either, just like Windows App SDK, but it does support hot reload. So you can basically have your application running. That can either be on desktop or on mobile in the emulator. You can make changes to your application and you'll see those app changes in real time. So you can get your interface looking really nice without needing the designer anyway. So you seemingly don't miss it if you have hot reload. The main thing about .NET MAUI is it allows you to create cross-platform apps built for performance and extensibility. You can define as much of your application in one place, and you can use Blazor Hybrid in .NET MAUI. So it is supported there. .NET MAUI can take advantage of the native APIs of target platforms, so an iOS API or an Android API, and you can even define platform-specific behaviors to leverage the particular features of that platform over the other platforms and give it some unique functionality if you like, but also create cross-platform functionality. So .NET MAUI or .NET Multi-Platform App UI is actually based on Xamarin, which uses Mono, and that was actually first released back in 2011. So it's actually one of the older technologies technically. They were then acquired by Microsoft in 2016 and later became part of .NET as .NET MAUI. It basically uses XAML. It's like Windows Presentation Foundation or Windows App SDK XAML, but it is different. Control names are different, supported controls are different, and property names are different. So it's just different. It's a little, and you can basically create those applications to target desktop on Windows with WinUI, same technology as Windows App SDK uses, or you can target desktop on Mac OS using Mac Catalyst. You can also write applications for iOS and Android, and even Tizen. There's Tizen support there, developed by Samsung. And all you have to do is install the .NET Multi-Platform App UI development workload for Visual Studio 2022.
It's a mouthful.
It is. Why they make it so long? I don't know. Make it hard. Just call it the .NET MAUI. No, why they do that? A great pro of .NET MAUI. Multi-platform support. The other two are just Windows. This one is not just Windows. You can do the other platforms as well. One odd con is if you're already familiar with like WPF and Windows App SDK, there's a little bit of a learning curve where you go, that's not what that control's called. I'm a bit lost now. What is this? So it is a little bit confusing. But if you don't know any XAML, this is fine. You'll be fine. But it's mostly just remembering what the differences are, like what the control's called. Like but what I haven't pointed out is like the screenshots of the code. You probably have noticed that it's changing. It's changed quite a bit from the other ones. So there are some differences you have to sort of keep track of, but nothing too major, and you soon get used to it. It's like anything, you'll switch between the two and but if you want to find out more about .NET MAUI, now to get started, you just go to github.com/.net/MAUI. So who's using .NET MAUI? So there's this sports engine application from NBC, and they basically use .NET MAUI because it allowed them to share code between their mobile, web, and backend APIs to deliver an application quickly to market. That was their key reason for using .NET MAUI. They wanted to get an application out there very quickly using a lot of their existing .NET code. What it supports is team management. So it's just for like, getting together, teams for like sports, any sport in the States, for example. Event scheduling, like when's the practice for a particular sport that you might be doing, and who's attending as well. Who didn't turn up for the game today? That's the kind of thing it's for. So really quite a useful application written in MAUI. So let's take a look at them. Any questions? That's good.
Good question.
Mhm.
You're going to get to repeat question.
Yes, I will.
EWTF like a decade or so ago. Is it still tied to the NVVM design pattern?
So the question was, is WPF tied to the NVVM design pattern? It kind of is. So you can still use that pattern. You can also just write conventional like handlers, like click events and stuff like that. But NVVM is still there as a kind of data binding kind of thing. When I show the demo, there's like hardly any code like behind because it's all done with that kind of thing. But you don't have to. You could have click events and stuff like you do normally. So you can have it as neat or as messy as you like, I guess would be the way of putting it. Yes.
Question from the chat. What's your opinion of sticking with WPF
Oh.
rather than going to Windows App SDK? Sorry, the WinUI.
Yeah, this is a really good question. And I wonder if next month's build might answer this question better for me. Because let's just say when you look at the session list for build, it mentions WinUI with WPF, but doesn't mention WinUI with Windows App SDK. So Windows App SDK is not talked about as much as the others. So it's kind of like for Windows Presentation Foundation, it's a bit of a legacy technology, but it is quite well supported, and there is sessions going to be talking about it at Build next month. So it's one of those kind of things like with WPF, you can stick with it. If you've got a WPF application already, that it kind of makes sense to bring that up to date with modern WPF because you don't have to change the UI. You can keep your old UI and swap the code out. At that point, you've got a few choices. So you could take your WPF app and switch it to Windows App SDK, which gets you a few more of the modern APIs, but you can use those in Windows Presentation Foundation as well. I suppose Windows Presentation Foundation is catching up with the UI stuff. The modern controls and stuff, you have to go third party at the moment, not for much longer. For .NET MAUI, that could be your next step. So you could bring your app along in stages. You could go WPF, then .NET MAUI, or you could go WPF Windows App SDK, .NET MAUI, or just Windows WPF Windows App SDK. But to pick a particular one is depending on your situation, I guess. But it's basically what's the one that Microsoft talks about the most is probably the answer to the question of which one you should support. I supported Universal Windows Platform back in the day. Expected with Universal Windows Platform to grow and evolve. Then it got cancelled. So I don't know. It's a hard question to answer, but luckily with .NET 8, the back end stays the same. So if you've made the wrong choice, oh no, Peter told me to use this one, he was wrong. Don't worry about it. Just have to take that same C# code, stick it in one of the others that I mentioned, and you'll be fine. So that's maybe the answer. There's always the other two, whichever two that would be. Okay. Cool. Anything else? Great. So we'll go for our demo. Okay, so what we've got here is a solution. Hopefully everyone at home can see it too. And just got a few projects in here. So we've got a common project with some .NET code in. So we've got our application provider. So this is just a simple class that defines our application and how it's going to work. It's just basically there's not much in this application. It's basically a notes application, and it has some methods to create a new note and a few other things as well. So you can see the functions the application has. If I show this other class, sorry, we've got a notes provider here, and I can just call out here. We're using our primary constructor. So everyone here, I'll just point it out. So like here, so this is the primary constructor syntax, which is a little bit neater than the old style one, which I'm actually using in the application provider. So I scroll down, this style one. So kind of this is the old style one. So the constructor's down here. So it's a little bit different, but a simple enough application. We have a model to represent our note. So we've got a title, we've got some content, we've got a background color for it. So not much going on there.
Zoom in just a little bit.
Yeah, of course. Sorry. Yeah.
Instead of worry about the UI, just to say.
Yeah, there we go. Sorry about that. Makes it a bit more readable. So I'll quickly show those in case no one can see that. So we've also got some SQL statements as well I can point out here. So we've got some great ones, all nicely without any SQL injection vulnerabilities, even though they shouldn't even be possible in a desktop application, but we've got all that anyway because we're good developers. And again, I've got the other constructor style here. So this is just a normal class library, effectively, with the .NET code there. So our first application is a WPF application. So what I'll do is I'll load the main window. And while that's loading, just wait for that to load. So we've got our two views here. So the top view, there's not much to this application, I'm afraid, but we've actually got a designer, so we can actually see stuff, which is pretty cool. So that's the one benefit WPF has over the other two, is we actually have a designer. But down here, we've also got our XAML view, which is what the other two will have. So we've got our controls here. We've got a button control, which is just to reload the list of notes. And we've got our items control, which basically is just going to show the notes themselves. And we've got a command bar. Now, this is actually the third-party ones because WPF doesn't have the command bar, which is the bottom bar with a little thing in the bottom right-hand corner. So this is using that third-party library. But once that support's been added, you'll be able to use this directly. So it'll be command bar, effectively. It'll be exactly the same as this, just without the UI namespace, because that's the third-party component we have. And then we also have some resources. So we've got a resource for the upsert templates. That's actually adding or editing a note, which has our data binding in. So we're binding to the title to the note. We're using two-way binding. So that's that interaction from the user. So when I type in, it's going to take that information and bind it to that title object or echo it out the other way. For content, it's the same. And for background, it's also the same. And we also have like some other elements there. For the actual background itself, we're using this converter. So I talked about the fact we can convert things. We're using a string to brush converter just for use our background color. You could have any kind of converter. You could have Boolean to visibility, anything you like. So if there's a format you can't display, but it would cause something else to happen, that's where converters come in really handy. But that's enough of the code. Let's see if we can actually see it. Or things got in the way, so we just have to find it. Oh, did we get that to go away? There we go. Okay. Let's just wait for that to load. Okay, let's show it on the screen because it showed on my screen. The feeling it would load on the screen.
Multi-screen settings.
Yeah. Come on. There we go. It is. So we've got our user interface here. So we've got a note already displayed there. We can create a new note. So when I do this, this will show our dialog. So this was the template I showed you. This is what it actually looks like. So we've got our title box. We'll just do hello. We do notes. Now we've got background color. Any particular color from that list? Green. Okay. So do green. And there we go. There's our note as well. If we've decided green's not our color, we can pick a different one, say, but blue, if you notice, it changes right away. Because we're using the data binding in real time, I can actually change color, but that's obviously not what I wanted to do. So okay, it's not goes back. So, so that's handy. So we're taking, so that's all we're doing is sharing that object between the dialogue and the background. I'm not having to do anything too clever. As long as it's the same object, it'll just show it in exactly the same way. So I'm basically taking advantage of that. So when I was editing that, that's the actual object that I've bound in that dialogue. That's the reason why I updated in real time. When I click cancel, I just put it back the way it was. So pretty simple. We also got a delete button as well, where you can delete or no. We don't want to, we'll keep that one. That's the WPF application. Nice and simple. So let's go to the next one, the Windows App SDK application. Any questions about the WPF one? No? Cool. Great. Cool. So we'll get the WPF one. So no designer this time. So nothing, sorry. But when this is running, you can make changes to the application and get the same kind of experience. Just it has to be running at the time. So this SAML is pretty much identical to the one that you saw in the WPF application. The only difference here is there's no UI here. And for everyone else at home, I'll point it out. So this time it's using the native command bar component that's part of Windows that we can actually use. WPF will be able to take advantage of that once it gets that as well. We'll have a quick look at the resources again. Again, pretty similar. In fact, it is exactly the same. It's just a copy and paste from the other projects. So the XAML in here is identical. There is no differences at all. One thing that is a little bit different between them, I'll show you the, this is probably wondering, what's that node control? So the actual thing we have. So this is the control we have. For the node control, the one in WPF is exactly the same. It's just a copy and paste. The reason why I can't share the same control is the namespaces are a little bit different. Now you can, there is a feature you can host something called XAML Islands, where you can basically host content from sort of UWP in like a Windows Presentation Foundation way. But this control is identical, so it's exactly copy and paste job from the two. So the code is very portable. So if we've got old controls in WPF that were in code, you can reuse them in Windows App SDK pretty much as is. But yeah, if I was curious about how that works, so all of this is just code, so you don't have to use XAML, by the way. This is a good giveaway. This is all just code of that you could, so this could all be a XAML control. I just wrote it in C# because I could, but I don't have to. I could create something called a templated control, which would basically be the same thing. But it proves if you don't like XAML, if I've not convinced you, don't worry, you can use this instead. So you can basically write in C#. So let's get the application working. So I'll just run this. And what you'll see is the application is pretty much identical to the other application because XAML-wise, it's almost exactly the same. Code-wise, it's exactly the same. So it's exactly the same. And as you can see, it's loading I'll just put it on the screen because you can't actually see that. Here it comes. Finding that. Mouse cursor is the hardest job. Here we go. So we've got our two nodes here. So we've got hello, the one we created before. We can change that. Just put an exclamation mark there, just for happiness. Now we can see that. So again, same application, slightly more modern looking buttons because we're using the WinUI buttons instead of the ones on Windows Presentation Foundations. If you did notice they looked a bit different, that was why. But the command bar is identical. The person who wrote that package literally took the open source code from Windows App SDK and wrote their own version of WPF. So they are exactly the same code-wise underneath. So that's the cool thing about them being open source. You can cross-pollinate the controls even if they're not supported between them. So that's Windows App SDK. So last but no means least, we've got .NET MAUI. So we'll just have a look at that. So here we've got it, and for everyone else, for here and everyone else at home, you'll notice right away, it's like, whoa, this is different. So this is not a copy and paste job. This is completely different. So everything's different. Why is everything different? So we've got like a scroll view, but to hold that flex layout, we were using a stack grid before. There's a button there because we don't have the command bar. There is sort of a command bar, but it doesn't look quite right. So I didn't use it. But the binding is the same. So the binding expressions are kind of very similar, but the XAML is very different. So that's the reason why it's a lot smaller, which is quite nice. There's not too much to it. For the resources, we've got those, and again, they're a bit different. So they're not again a copy and paste job. There's also some missing as well. So these I've done the deleting of a note a little bit different than I did in the other ones because I'm taking advantage of the native APIs for the actual dialogue. So there's a dialogue to delete, which I showed before. There's a different dialogue. I'm using the actual platform one. So if you're on iOS or Android or Windows, it'll show the right dialogue for you. But for the actual dialogues themselves, this is how I've done them. So I've used the .NET MAUI toolkit in here to help out with a couple of things. So it's got the string to brush converter built in, so I've used that. And we've got this layout for our dialogue. So I've basically defined a dialogue here. I'll run it on Windows. Fortunately, the emulator is not playing today, so I won't be able to show the mobile version, so sorry about that. But we can show the Windows version instead. Just let that one load. But yeah, the main benefit for this is if I had a Mac or iOS or Android or whatever, I could run the same application, those devices, and it would work in exactly the same way. So I'll just get that loaded on the screen. Step. Right, there we go. Okay, so this is the same application. The UI is a little bit different because the styling of the controls, we're just using the .NET MAUI default styles for all the buttons. I could have styled them the same exact way as they look on Windows if I wanted to, but this way it can run cross-platform. One slight difference here is .NET MAUI has like font embedding, so I can embed a font that I want to display. So I'm not using the Sigu script font, but I'm just using a third-party font. I can't use Sigu script because of the licensing of that, so I can't embed it in the application. But if I had the license, I could totally do that, or any font you like. So we have a script font here that basically does the same job. If I do delete, I get the Windows dialog style. If this was on iOS device, it would be the iOS dialog style. If it was on Android, the Android style. So that allows me to take advantage of the native looking controls. I don't have to build something that people won't recognize. They'll go, I know what that is when they use it on their particular thing. We can also create, I'll do the edit mode. So again, this dialog's a little bit different because of the way I've had to implement the dialog, because there isn't a native dialog control per se, but there is a pop-up control in the .NET MAUI toolkit, which basically does the same job. So that's what this is. So I can change the text again. I can put an exclamation mark in, save that, and it updates it. So that's the three applications. And I can also show you what the control looks like as well. So the control is a little bit different. So we've got the font, it's Calligraffiti, and we have that here under fonts. So we've got the font there. So you basically just drop the font in there, tell it to use that font. Mention that's how that works. You can see the code here. It's a little bit different. Controls have got different names. We've got, for example, it's like this label property we've got. There's a label control. It's text block in WPF and in Windows App SDK, but it's label in .NET MAUI. Those are the kind of differences we're talking about. Nothing too major. They still make sense. But yeah, so any questions about the code or any of those? Anything from online? Yes.
Well, it's got the XML namespace stuff. Is it craft to kind of manage those or does it come naturally?
Luckily, I mean, it's just to repeat the question is asking about the namespaces. So luckily for all the first party controls, there's no real namespaces to worry about. There's only third party ones, and it's, so it's quite straightforward to like define a namespace, and all the namespace does is point to the implementation of that. So I had one called controls that pointed to my node control, then it would just be controls colon the name of that. So they don't get too difficult. Third-party libraries might have a lot of controls like that WPF one, so they'll all be just UI colon whatever UI command bar, like the one I showed. There's others as well. So it doesn't get too much. I mean, if you're using loads of third-party libraries, you can have loads of namespaces, but they're going to be quite clear at the top. You'll have like, even if you have 20 of them, you'll have 20 namespaces with them all pointing, and they'd all just be prefixed differently, but you might not be using that many, but it doesn't get too unwieldy. Luckily, if you keep them quite short, and you get IntelliSense, of course, as well. So once they're referenced correctly, if you type ns colon, you'll see the kind of, or whatever the namespace is, you'll see what the controls are. So it is a little bit easier. There is some help there from Visual Studio to make that a bit easier for you. Anything else? Oh, cool. Right. So I'll just get my slides back. So XAML Notes, that was the application I showed off. It basically has a class library that uses packages from NuGet. It used SQLite, if anyone was curious what it was using for the storage there. And it was actually using the same instance of the database. That's the reason why each of the applications had the same notes, because they were all talking to the same file. And it also used some extensions for dependency injection. So I was using the latest dependency injection, all that stuff. So you can check out the code later and you can see how little code there actually is there. It also takes advantage of my toolkit, my Commensus toolkit for all the data binding. So I'm using cross-platform data binding, but there is data binding in the other toolkits. Spare might as well use mine because I've got it. So the WPF one, that used that modern WPF UI to get the controls at the bottom, the command bar, because it's a nice looking modern control and we could use that. And that's identical to what was used in Windows App SDK. Windows App SDK one, that pretty much used all the built-in functionality of Windows App SDK, except for one thing. The actual the binding of the colors was using a color helper from the Windows Community Toolkit. So Windows Community Toolkit's got loads of stuff in it, but it saved me from having to write a color binder. So that's why I used it there, but I could have used it for more than just that, of course. The .NET MAUI one, that one used the pop-up control, which is provided by the MAUI Community Toolkits. That's the thing. If there's something missing, it's probably in one of the toolkits. So I wasn't able to show the mobile version, so there's the screenshot of it. It's basically exactly the same application, just flowing for a mobile device. So if you did UWP back in the day, then you'll know how you can sort of scale an interface. But yeah, again, took advantage of a toolkit, because why write code again when someone else has done it better? I mean, done it instead. So .NET 8, that is the latest version of .NET, and that was released just in November 2023. And that allows developers to build modern applications and services for any. XAML, that allows developers to create modern-looking applications that decouple the UI from any data, and that uses data binding to make that interaction work. And that can be from values in code or from values that the user has entered. Windows Presentation Foundation, that allows developers to build WPF applications that can target Windows 7 right up to Windows 11 using the latest .NET and XAML for the UI. Windows App SDK, that allows developers to build a WinUI 3 in desktop application, and that uses XAML and takes advantage of .NET 8, and you can target right from Windows 10, 1809, all the way up to the latest version of Windows 11 and beyond. And then finally, .NET MAUI allows developers to build cross-platform applications. So I wasn't able to show the mobile one, but if you download the code and try it out, you'll probably be able to get that one to work. But you can write cross-platform apps for Windows, Mac OS, or mobile, as well as Tizen as well, which was supplied by Samsung. That's it. That's me. So I'm Peter. I've been a .NET dev since .NET came out in 2002. Live in Gateshead in the northeast of England. I've got post articles and a podcast about XAML, .NET 8 and .NET MAUI as well. And that was my last episode. And I've also got tutorials and workshops, including ones on Windows App SDK, because that's my thing, at tutorialer.com. And you can find me on LinkedIn and GitHub. By the way,
Sure, I've got some questions.
Yeah.
If you had to add one feature into one of those languages or one of those sets that the other one is or one is got, what would you pick?
Oh, what are the other ones have got? Ooh, that's an interesting question. Well, I mentioned it. Windows App SDK is missing Blazor Hybrid. That's a real disappointment, to be honest. Windows App SDK has got a lot of things going for it, but that's not supported. But .NET MAUI does. So .NET MAUI targets Windows with WinUI and supports Blazor Hybrid, but Windows App SDK does not. So it's kind of like a weird missing thing. The stuff that's missing from Windows App SDK from UWP as well that's being brought over. But that does feel that's the one that really I'd like that because I like Blazor as well. So as like a Blazor developer, I kind of want that to be there, and I would have shown a demo like that today if I had that functionality because I've done something similar with Blazor, but because it's missing from the demo as well. So that's really the main one. It's like it's nice to say, yeah, Blazor's in .NET MAUI, Blazor's in WPF. Yeah, it's missing in Windows App SDK. Windows App SDK is the one that I like the most, but that is a real problem that it's not supported. I don't know if it'll. I don't know what the plans are for adding it. It's not impossible, clearly, but I don't know. It's not on the roadmap. I think there's a roadmap because it's all open source in the community and stuff. So there is some community feedback. They're adding new controls. Some of the controls I've been asking for a couple of years, but they're finally adding. Ink Canvas was the one I was thinking. Windows App SDK is missing inking, and they're adding that probably in the next version, but probably the version after that. So you're talking about a year from now. But for Blazor, that's the missing one. That's the key one that I would like them to add, absolutely. So someone can make that decision out there. That would be pretty good.
Is Blend still a thing? Remember Blend?
Yeah, that's an interesting question, actually, because in theory, yes, you can sort of pull it off, but it's a bit weird. So, like, if for anyone who doesn't know, so Blend is basically the sort of designer's tool. You had Visual Studio for developers, and Microsoft had this idea of Blend for designers. So you basically go, there you go, designer. You make this look really cool. I'll code it, and we'll bring ourselves together. It was really good, and it's still around. In fact, if you type in Blend, it's probably installed on your machine right now if you've got Visual Studio. But if you try and create a project, it creates a project WPF, yes, but it's the .NET framework WPF, but the XAML's the same. So yes, you can do it. So what you do is just create a legacy WPF application in Blend, do all the design work, take that XAML, pop it in your Visual Studio project, your current WPF one, and it works because that's how I've done my tutorials. So I have my Windows App SDK tutorials. I did a whole set of custom looking controls. They were all done by messing about with things in Blend. I'm not a designer, so they're not very good, so don't be too critical. They're all just some variations of the salmon color for some reason, because I thought that'd be funny. But yeah, you can basically you can use Blend, create your UI in WPF, the old WPF, and take that XAML, and it works just fine in Windows App SDK and modern WPF. Not MAUI, because the XAML is different, right? But you can still probably take some of the pieces and just change them. So if it's something like a button, you just have to change some of the names of the properties. But yeah, the Blend tools, they'll still work, but you have to go through an extra hoop. But it's possible because I've done it.
Oh, good. I used to love that way back in the day.
Yeah,
Yeah, Samuel for that long. Oh, sorry.
yeah.
Must be 15 years, maybe.
Yeah, 2006. So that was the promise of XAML. The devs would do the code behind, and the designer would make it look really cool. And in fact, things like Uno platform have like the Figma stuff, so you can get your designer design a UI in Figma, and they can go, "Can you make that work?" And they're like, "Yeah," because that's totally. There's basically literally a plugin for Figma that will allow someone to produce. So, Uno platform's kind of delivering on that promise of Blend. Microsoft had this really great idea and they haven't gone with it, but other people are doing it now. So yeah, it's a shame that it's not fully supported, but Blend was that ideal. Yeah, the Photoshop for applications, effectively, if you're not too familiar with it, you could change every aspect of a control. You can make it look like anything you like, but fundamentally, it's still what it is. It's still a button or a checkbox or a drop down. So from a coding point of view, you don't have to do something weird to make the button work. You just go, yeah, it's just some XAML. It just looks like this amazing UI that I could never design in a million years. But yeah, you can totally use it. You just have to go through that extra step. But yeah, I know for a fact that's possible because I've done
Any other questions? Glenn, please start here.
it. Yes,
Three demos, which was the easiest one to write?
the Windows App SDK. Because that's what I do. The WPF one was basically exactly the same. So those two demos are identical. So
Right.
so the WPF one was kind of first, but the Windows App SDK one was the easiest, right? Because I was most familiar with it. But those two about the same time, if you like, they were very easy to do. The .NET MAUI one I struggled with because of the differences. I didn't know what the equivalents were.
Your learning curve.
That was my learning curve, yeah. So that took me a little bit longer just to go, what's the equivalent of that? So that was where. But if you're a new person coming in or you're learning both at the same time, it's fine. It's just I've got 15 years of WPF XAML in my head. And it's very hard to go, oh, that's that different. So that's why I found it a little bit tricky, but it's very easy to overcome. I eventually got there and was able to put it together. And that was my first .NET MAUI app, by the way. I've never done .NET MAUI at all till I wrote that demo. So I'd done WPF and Windows App SDK since they started, but .NET MAUI, that was my first .NET MAUI. Yeah. Currently my only one.
First one, man.
First of many, yes.
How are we installing, other than Maui mobile apps, which make a case, obviously, but how are we installing anything for Windows these days? It used to be you have to use the Windows Store.
Yeah, you've got a few choices because you can do the Microsoft Store still, so you can put your apps on the Microsoft Store. You can also do MSIX, so that's like the more evolved version of the MSI installer. There's even a streamlined installer experience for the store now. They just launched. You can click a link and it'll produce an installer for your application. But for WPF, you can do whatever you want. So I wrote my own installer for that application that I showed off. I wrote a custom installer in Windows Forms, which is really hard. Don't do that. But it was because there was a specific use case for that application that required a custom installer. But it basically it's just the only thing about WPF is it's not got a self-contained executable yet. So when you do generate the executable, there's a couple of DLLs because they're the proprietary ones. But I think that's getting solved at some point, I think. But yeah, the installation experience is just for the other two. It can be an installer. You can just write your own installer if you want, or use a third party one. That's a better idea, probably, to be honest. And for Maui, yeah, you can just distribute that out whatever way you would distribute an application on those platforms. Yes, but yes, you've got more choices than you would have had, say, on UWP, for example. So it's not bad.
Check and see if we've got anything in the chat.
Yeah, yeah. Don't want to miss any questions from people from home.
Our rebel representative has disappeared, so I'm assuming pizza may be here. So,
Excellent.
so
Great. Brilliant.
thank you very much.
You well? Yeah, thanks.
Hey folks, so we're going to take a short break and eat our pizza. If you too would like pizza, then come along in person to BGSS in Nottingham and you too could eat lovely pizza, drink lovely drinks, all those things. I'll leave you in the capable hands of Connell, who, may be eating his own pizza, who knows. But we'll back probably, I'd say, realistically 10 past. So it's 20 minutes, so 10 past 8, we'll be back around then. To give you enough time to go and do whatever you need to do. And then we'll carry on with Simon Pater talking about basic ML algorithms. So thanks again for coming, and we'll be back shortly. I won't put any hold music on because that'd be embarrassing. See you in a moment. Hello, folks. We're running just a couple of minutes behind. We're still here. We will be back with you in just a minute. Hey folks, we're coming. We're just getting Simon set up now. So we're walking this way.
Even got, which is actually a perfectly normal way of walking, not what it might sound like. Ah, we've got to go. And link to copy link. Right.
Tweet it to me. It's probably the easiest.
You'll have it in seconds.
Cool.
And I just literally need a 5-second disappear to the other room, and then I'll be all good to go.
Yeah, well, I'll get it up while you're doing that, so to speak. So
Before I go, just confirm that that link is there and working for you.
Twitter. Switch to mine. Straight to where the glass is and turn left, and
Right.
then you'll see
I
the
just wanna make sure
door.
this
Yes,
works.
send the link. There it is.
That looks like it, yeah.
Cool.
Right.
Woo, Paul.
Be as quick as I can.
Apologies for the delay, folks.
Pizza was too nice.
It was the pizza was late, and then it was too nice afterwards. So that was the reason for that. But apologies, I know we've made you wait. So and just now plugging things in.
Yeah.
Right, so should be able to hear you. Can you just speak, Connell?
No. Yes.
Oh, I'll take that as a no then.
Mm,
Should be there.
going. I've got
All right, doesn't matter. I'll let
That is a
you.
really cool background.
Prince of Persia.
That's fantastic.
No,
You draw it.
although no, that's about, and pretty much everything you can see there was Jordan Mechner. Just released those. If you don't know, that's the creator of Prince of Persia. The folks at home can't see this. It's shared on my screen there. So
This is what you guys get for not coming in.
yeah, we'll probably just duplicate this. I guess it's going to be the easiest way.
And also, that is the best non-alcoholic beer I've ever drunk.
Told you, it's very good, isn't it? Duplicate. To change this to 1920 by 1080. And then folks will be able to see that, keep that. Switch to this, go to there. Start
go.
presenting, which is skip opening PowerPoint for the web, maybe. Probably the best idea. About right. And then at that, we should be able to start the slideshow. Come on. Yeah, and then
What
we
was it
should be
first?
able to
I was
F11.
in London yesterday, where it was more of a comedy thing where you explain how neural networks work very simply.
I'll do my best.
No, should be able to make that full screen, but that's as close.
F11?
Well, I press that and there we go. Right, now next.
You can
Zoom.
press the other F11.
Yes, exactly. Right, and then share my screen. And share just this. In fact, should be able to just share the PowerPoint presentation because that's you've got no code. It's just this, yeah.
Just slides,
Cool.
nothing else.
That's fine. No worries.
I've seen enough live coding demos go wrong to never ever do one.
Yes. Right. So in theory, okay. Turn the volume. That's why I couldn't hear anything earlier.
Hear me now?
Yes. Now I can hear you now. So
Yeah, we
that's good.
slide.
That's good then. Just one sec. I'm gonna switch this to. It's like Inception. Hey, yeah, steady. Don't forget, I'm in control after this. All right, and then
Take nearly any surname over mine.
yeah, it doesn't come out of there weirdly.
Particularly ironic.
All right, that'll come out of there. That'll be fine. And then we'll.
There's no sound or anything on mine, so
No, that's all right then.
I'm really low. I'm weirdly low tech when it comes to slides.
Yes.
Accidentally joined the guitar track. Oh, yeah.
Right. So, talking, Peter, where's that coming out from? That subtitles is on for some reason. Why is it doing that? Oh, I'll get rid of that lot then. Probably. Oh, okay.
Let's stick it out. It's fine. It's good enough.
Yeah. Cool.
Right. Just gonna.
There it
Lovely.
is.
Right.
Hi,
so
folks. I'll take a seat.
where's my? Is it just round here generally? This is where I need to stay.
Yes. Yeah. Exactly. So, shout if don't die because we'll need you.
To say how much alcohol's in that non-alcoholic beer.
Yes. Yeah. Lots. So yeah, shout if you can't hear us. But other than that, Simon Painter.
Hello. Yes. Shout if you cannot hear me whatsoever. Good. Great. We'll proceed as planned. So, I am going to talk about machine learning algorithms. I have become very, very interested recently in machine learning, partly because I like maths and partly because it is basically magic. And apologies for the slightly inaccurate depiction of Athena there. I know, wrong eye color, wrong style of helmet, and where's her Gorgon shield? There's a load missing. As I mentioned, I'm also an ancient Greek nerd, which is why I went with the ancient Greek theme.
She definitely doesn't use that keyboard. She uses that split keyboard.
Something like that. But I mean, sure, it's an AI, but grey-eyed Athena, you had one job, grey eyes. It's literally in her epitaph. Anyway, fine, let's move on. This is not a talk about ancient Greece. Or is it? Because apostasme. So hello in ancient Greek, because I've been learning ancient Greek because I am that sort of level of nerd. But also a bit about me. I've been, well, I don't know if I even need to bother anymore. I've been doing this a while. I'll still be doing it probably in a few years' time or so. Still working for Muller these days. I've been here enough times, I'm not going to go through the rest of that. I have a book out for anyone that didn't already know. Pete is modelling a copy of it. Here is my glamorous assistant over there, modelling it so elegantly. There we go. I have a book out. It's not on machine learning, but it is nevertheless a book, What I Wrote. And be warned, I wrote it. And it is very, very silly. I mostly wrote it between the hours of midnight and 3 a.m. because I have children. And so the book is the most ridiculously random thing because I am tripping on pure tiredness. And weirdly, every now and then I had a stupid idea about something that I thought would be funny. And I told O'Reilly about it. And then I expected them to turn around and say, stop it now. It's gone too far. And every single time they said, we love it. We're just trying to work out how to do that. Anyway, but that's not entirely on topic, but nevertheless, it exists. And this link here will give you a free month with O'Reilly for anyone that wants it. Okay. First, machine learning. So just to clarify for anyone who's not already aware, machine learning is a subset of AI. That is, all machine learning is AI, but not all AI is machine learning. It is a subset. And there is a subset of machine learning called deep learning. I am not going there today. This is focusing entirely on that middle category, the just machine learning bit. And first, I want to talk about a pile of books, because that's where I thought would be a good place to start. Since, this is an ancient Greek theme here. And there was a chappie in ancient Greece who came up with a series of paradoxes. And one of them was the paradox of the big pile of rocks. So let's imagine that I've got myself my space here, and I'm going to take a rock, pop a rock on. Now I've got a rock. And I could ask you, is this a big pile of rocks? And of course, you're going to say, no, that is a single rock. Okay, let's have another go. I get my rock, pop that on there. Now I have two rocks. Is it a big pile of rocks yet? No, it's not. And I'll keep going, and I'll keep going. Eventually you'll say, yes, it is now a big pile of rocks. Great. I'll take one off. Is it not a big pile of rocks anymore? The point is that there are certain things it is hard to put definitions to. They have fuzzy boundaries between whether it belongs to a set or not, whether it is this category or this category. The boundaries are fuzzy and hard to define, and politicians are all too aware of this because there are certain things that if you try to put a rule to this is defined as this many, bless you, this is defined as this many, you will always find examples that make the whole thing ridiculous. Such as this, by the way, is called the Sorites problem. And this has existed for at least something like 3,000 years, and it is to this day an unsolved problem. Because how can you ever solve something like this? But machine learning is an attempt to allow a machine to think fuzzy. That is, normally when we code, we will say the boundary is this, and then that boundary is this. With machine learning, you can be fuzzy. You can give vague definitions, clusters of symptoms, and then leave it to the machine to make its best judgment based on the symptoms that are presented. So that is what it's for. Okay, but first I'm going to talk about super top trumps. Like all good dads, I like to play games with my children. I have 2. And like all good nerds, I want to make sure that I win. So are we all familiar with the rules of super top trumps? Now, this is specifically Harry Potter edition, because this was the edition that we had to hand. My children did wonder why I wanted to borrow the cards for a while. This is why. Does anyone confused about the rules of super top trumps? Because now is a good time to say, because that's fine. That's fine. That's,
I know top.
it costs more. That is okay. So briefly, the rules of super top trumps, Harry Potter edition. We have got a card. Each card corresponds, in this case, to a character played by an actress who should never be allowed to sing. I've seen Beauty and the Beast. Please, please stop her singing again. Okay, and there will be a series of statistics about each of these personages listed down the bottom there. We have first year at Hogwarts, wand length in inches, keep it clean, guys. Family tree, fear factor, and super top trumps rating. The challenge is you split the deck between all players. One player is the first player. They draw a card. Everyone else draws a card. The first player says, I choose, I don't know, super top trumps rating. Everyone else says what they have. And then whoever has the highest rating in the round wins all of the cards in the round. That winning player then becomes the new first player. Play continues until one player possesses all cards. This isn't entirely relevant to this, but it's still interesting. It's also a game that can potentially last forever. Trust me, I know. So, super top trumps. I decided to see what I could do with some basic statistics to help me to play better at Super Top Trumps Harry Potter edition. Here is the complete data set of all of the cards. Notice there are some unknowns now. There are actually machine learning-y ways and statistic-y ways of filling in those. I've only got about an hour or so. I'm not going to go all the way into that sort of level of detail, but in the real world scenario, you would probably have some additional processes that run before this to fill in those blanks with estimates. For now, I'm just going to ignore them. So fine. I don't know what on earth to do with the unknowns either in the game. The instructions give you no help. Does unknown win or lose? I just don't know. And incidentally, first year wins by being the lowest value possible, unlike all other values, which are highest value wins. That is, the longer ago you joined Hogwarts, the better your chances of winning the round. Okay, so there is my data set. What I want to do is to try and determine, given a card, what is the most useful characteristic to select. So let's have a look at some basic statistics. Min, max, I think we're okay with these. If they are not, what are you doing here? Okay, mean, median, mode. When most people say average, they are using the term imprecisely. When most people say average, what they mean is mean. Mean is add them all together, divide by the number you got. The classic average, that's mean. There are a couple of other ways of expressing these sorts of ideas. Median is line them all up in order and choose the one in the middle. Or if there's two in the middle, I think you take the two and do a mean of them. Something like that. And then mode is whichever one is the most common. So in a lovely bell curve, distributed data, a normally distributed data set, the mean, median, and mode all ought to agree with each other, at least roughly. What you could see in my data set is they don't agree. They are quite different, sometimes radically different, which suggests that my data skews one way or the other, which, spoiler, it does. So what can I use to look at what might give me an idea of what is an outlying data set, which is effectively what I want to do with Super Top Trumps. So first thing to do is calculate the variance. The variance is the amount to which it varies from the mean. So take each number in the set of numbers and then work out first that individual number minus the mean of the entire number set. I think I've got, by the way, before I put these slides in the wrong order, but a brief ancient Greek lesson for beginners. The letter sigma there that looks like a giant E means add them all together. The mu, which looks like a sort of U with an extra tail on there, means take the mean of them. I have tried to use sort of generic, vaguely linky looking terms for most of my algorithms, but it ended up being so wordy that it just filled the screen if I didn't use these two. And they are so ubiquitous within maths that you'll probably come across them sooner or later working at this stuff anyway. So if you see the mu, the U thing, that's all that means. Okay, returning to this. I'm treating it like a function for the purposes of making it look more like something that software developers like myself might find familiar. So first calculate n minus the mean of the whole set of numbers. Then take that first number and square it. And then do the sum of n2 divided by n2 length. That is the how many you've got, the count. So that gives you the variance, which is how much you're varying from the mean. And then from that, you can calculate standard deviation by just literally taking the square root. Now, in a standard deviation set, what you would tend to see is the mode would be the one that's at the top of the bell curve, and then a standard deviation one way or the other from the mean would contain, was it something like 68% of all of the data in the entire set? But that's not going to work in our case because we do not have a normally distributed data, as you can see over here. In fact, we have got a standard deviation on year of 23. We've got a one length standard deviation of 2.5, stuff like that. And scarily, the family tree standard deviation is 6. Now, the min is 0. The max is 10. So it doesn't matter really what your mean is. 6 either side of whatever number you've chosen is the entire data set. It's clearly not normally distributed. This is actually what it looks like if we start plotting charts, but at least that gives us an idea, vaguely, of how far an outlier you are. So you can see there are a few interesting outliers in this data set. You might notice that there's a 1900 outlier in first year. I don't know if anyone can guess who that might be. It is Dumbledore, because apparently he joined Hogwarts in the Victorian age. Apparently, I didn't know that, but fair enough. Michael Gambon's been around a bit, I suppose. But with everything else, what you're seeing is a really early mode, that is most common value, on one side or the other, and then a really, really long tail coming away from it. Except for top trumps. Oh, this thing's in the way. Can I move that? There we go. Top trumps rating, which looks like they just basically assigned one number to each character by the looks of things, except for 2 or something like that. But everything else, so it looks like statistically my best choice when playing Harry Potter edition here is probably to find out what's the mode and then just see if I'm either on it or not, depending on what I need. With Fear Factor, the mode is actually the worst value. With Family Tree, also the worst. And Wand Length, yeah, in fact, all 3 of those have the mode as the worst. So it looks like work out what the mode is and go as far from it as possible. So at least it's got me something. And the standard deviation might give me a feel for how far away statistically I am from the mode, but how accurate is in this case. So what about trying to make predictions? The first thing you need to do is to work out how much do they correlate. Now, correlate is the degree to which 2 entire columns of data correlate with each other. This results in a value between -1 and 1. 1 means they correlate perfectly. Now, by correlation, I do not mean they are the same value. What it means is that they move up or down in ratio with each other. You double one, roughly speaking, you double the other. That would be a perfect ratio. You never get those in real life. -1 would mean they effectively have a perfect inverse ratio. As one goes up, so the other down. 0 means they have no relation. They're basically random data. Chuck it away and start again. That's what correlation is, and this is how you calculate it. So X I'm defining as data set 1, that is column 1, whatever column 1 is. Y is data set 2, that's column 2. And then for each of these, X and Ys, work out first X minus the mean of X, Y minus the mean of Y, AB, which is A multiplied by B, A squared, which is A by A, and B squared is B by B. And then finally, correlation is a sum of AB divided by the square root of the sum of A squares multiplied by the sum of B squares. But basically just stick that in your code, and you don't really need to worry about memorizing that because you can look it up unless you're really interested. And this is what happens if I run this on every single data item in my Harry Potter Super Top Trumps and then work out its correlation with everything else. This is a heat map. The one red diagonal down the middle there, that is the data item correlating with itself, which of course means it correlates perfectly with the one. So you can ignore the one. And in fact, if you look, basically the bottom left and the top right are mirrors of each other. So you can just think of it as a stair shape, but you could look either side. So strong correlations here. We have non-super duper strong, but we have a few that are interesting. Super Top Trumps rating correlates 43% effectively with wand length. Does that mean more awesome wizards have longer wands? Maybe. Maybe. What else do we have? We have a 40% correlation between wand length, sorry, a minus 40% between first year and wand length, suggesting that as time goes on, so the wand length becomes shorter. Is that significant? I don't know. It might be. It might be a trend in wizards' wands. I couldn't tell you. And there is, sorry?
Miniaturization in technology.
Miniaturization in technology. I like that. Yes, I think that could be. It could be that it's that. This is where we can only speculate.
Talk about Hollander.
Ask whom?
Hollander.
Hollander. If I ever run into Hollander, I shall ask him. Okay, and fear factor correlates with, where was it? Family. There is a minus 42% correlation between fear factor and family, as in how many family are you known to have? And it's a minus 42, which suggests that the more family you have, necessarily the less scary you are, which, yeah, I can see that actually. Famously, Lord Voldemort has no family and is, quite scary. Ron Weasley has quite a lot of family and is not scary. So let's talk about a more interesting data set, because that one hasn't got enough strong correlations in for me to find especially useful. So let's talk about Pokemon. I am quite an avid player of Pokemon Go. And I'd never even played any Pokemon or watched any TV series or anything before this, but I quite enjoy Pokemon Go. So I thought I'd use Pokemon as an interesting data set. Here is a data set that I found on Kaggle, which is a fantastic site if you wish to learn all about data science and machine learning and so on. And it's a data set of all of the Pokemon up to a certain point. I think there's only about a couple hundred entries here, which I know there's a lot more of those these days, but still, it's quite a lot. It's enough for me to make some data correlations with. So we've got things like their attack value, their base egg, which is something like how many steps do you have to take before they get an egg, experience, I think it's how much before they level up, height, weight, hit points, you get the idea, defense. Types is a tricky one, and I'm not going to go into those. There are ways of doing that sort of correlation, but for now, I'm not going to go into it. And are they a legendary, which is a 1 or a 0? A legendary being an unusually rare and special Pokemon, usually especially good at being stumpy. That is, beating up other Pokemon, because apparently this is a fine and acceptable thing to get kids to do. Or something. To be honest, the biggest puzzle for me is, why on earth don't you just get your fire-breathing Pokemon and just torch those suckers from Team Rocket, and then they won't bother you ever again? Problem solved. I do not understand why we have to just get put anyway. Fine. This is why I am not allowed to write Pokemon. So this is the correlations between all Pokemon's stats with every other one. So what strong correlations do we see here? Well, there is an 87% correlation between the number of steps required to drop an egg versus being a legendary, which makes sense. Legendaries are hard to get, hard to obtain. You don't want people suddenly popping in and getting loads of them. This said, Pokemon Go is such that the sort of world-breaking awesome power that is Mewtwo, there's only supposed to be one of. I have 40. I think it's at the point where you're supposed to just think game logic, and let's not go any further with it. We have a minus 48 correlation between hit points and capture rate. So something with more hit points is harder to capture. Makes sense, I suppose. It's probably bigger and meaner and harder. Generally, there's a whole load of correlations with capture rate. Minus 45 with defense. So minus 38 with minus 38 with height. So so things that are bigger with stronger attacks and better defense tend to be harder to catch. That makes sense. Generation corresponds 99% with Pokemon number. This is interesting but useless. Pokemon number is effectively an ID value assigned to each Pokemon arbitrarily when they're invented. And generation is basically an arbitrary block of Pokemon, about 100, 200 at a time. So yes, absolutely, generation goes up as does number. It's true, but it is of no interest whatsoever because none of those numbers mean anything except to people who collect the cards and so on.
Are those numbers still useful for the data scientists, say, to make sure the data set's working? So other than that one correlatory diagonal, if there was other data in there that you know should correlate,
Correlate.
that one, too many Guinness zeros, then that sort of number can be useful as a data check, I guess.
Okay, so you're saying could that be useful as a data check, as in basically like a control?
Yeah.
Like, yeah, I suppose so. It's flagging up. If I didn't see that flag up there, that would probably be a warning sign to me that clearly my correlation algorithm is not working.
Yeah.
Could be, yeah. So there's enough here to actually then start to put together an algorithm which can make some predictions of how we map from one data set into another. This, by the way, is how height and weight correlate with each other. These are the data items I chose because they correlate pretty well. And they're both numeric data items. The first algorithm we're going to look at is about mapping one set of numeric data to another. That is continuous data, where we start at here and go here, and it could be anywhere in between. So there is a sort of vague, scattery along correlation. It's very widely distributed, and that's because Pokemon are all different species, and there was no real intention that they should all line up. If I got 1 million Pikachus and took each of their data, heights and weights, you'd probably find a really nice line there, but I am not interested enough to do that. So, you know, but broadly, the tendency is that as something gets bigger, it gets heavier. There's some weird outliers like Whale Lord, which is colossal but flies around in the sky full of helium, so that's very light. You know, your steel ones, which are tiny and weigh absolutely tons. So yeah, there's a whole load of outliers, but still, there's a broad line there, which might be useful. Linear regression is my first algorithm, which I'm going to show. And as I say, this is mapping the continuous source property of, say, height into the continuous property of weight. And this is how you calculate it. Another for each. Calculate xy, which is x multiplied by y. You've got x squared, xy, and y squared. Fine, that's our base set of stats for each column. Now we need to calculate a couple of items. We're basically making a linear equation out of this. So we need an intercept and a gradient. The intercept is the point, I believe, at which it crosses the x-axis. Y-axis, darn it, always doing that. And the gradient is how steep is the line. There's your algorithms. There you go. Count multiplied by the sum of all xy's minus the sum of all x's multiplied by the sum of all y's divided by the count multiplied by the sum of all x squared minus, yeah, that's what it is. I did this in Excel, so you don't, it works. And then the gradient takes the intercept and we do the sum of y minus the intercept multiplied by the sum of all x's all divided by n. That is the number that you've got. And that gives you an equation, which is y equals intercept plus gradient multiplied by x. Here is my equation that I worked out just using straight data like that. The weight of a Pokemon, according to my equation, is 12.5 roughly, plus 63.5 multiplied by the height, which means that in theory, if you had a Pokemon whose height was 0, then it would weigh minus 12 kilos. I'm guessing that just literally never happens. And roughly speaking, a meter of height corresponds to about 63 kilos of weight. Vaguely right, and this is how it maps. So that is the data set of height to weight, and that line is the line that results from the equation, and it's a pretty good fit as far as can ever be with a spread out data set like that. It kind of works. And if now the next thing I want to do is work out how accurate is it. So I need a measure of how well I have modeled the data set. So error, there's basically an error equation, which tells you how well you've done, because it's not good enough just to have an answer, you've got to check it. So you first need to calculate the total sum of squares, which is the sum of y minus the mean of y squared, then the residual sum of squares, which is the sum of y minus the calculated value I came up with, squared. The reason for the squares, by the way, you'll see a lot of squares in this. There's two reasons for that. The first is that it forces it to be a positive value, because if you multiply negative by negative, then you get a positive. And The other is that it forces outlying values to be more statistically significant. Things closer by the mean will be less significant. Things further out will be massively more significant. That's the reason for all the squares. That gives you what's called the R² value, which is 1 minus the RSS over the TSS. That gives you your error. My R², that is my error. That is how well does it fit. 0 means terribly, 1 means perfectly. And that gives me an R² of 39.7%. That is 39.7 fitness for purpose. So it's okay. It's not great, but it's something. Can we go a bit now? If you want to see an example of a data set which does match perfectly, here's one I got off the internet. I like this one. These are some data columns. The first column is year. The second and the third are my data that I'm going to try and model. So if I run this through Excel, because Excel, believe it or not, is one of the best things ever for doing machine learning in many ways. It's weird. It's as much of a surprise to me as you, but it's true. It works really well. So work out my ABs, my A1s, B2s, and so on. The correlation that I worked out is 96.39%. That is a very, very high correlation. So it sounds like I'm onto a winner here. That's what it looks like charted on a graph. That looks pretty good. This is the data set 1 to data set 2, and they correlate into a nice line. Good stuff. So let's start making an equation. Here are my intermediate values. And that gives me a gradient of 603, an intercept of minus 7,653, and there's my equation. Okay, and that's how the orange is my equations line, and the blue is the actual line. So you can see how pretty closely they model to each other. That's great. It's got an R², that is fitness per purpose, of 96.4%. This is great. Now, what's the problem here? Well, the problem is what these two data items are. They are the profit of Google mapped to the sales of cheese in the United States. They correlate perfectly. Now, is there a causal relation between those? I couldn't tell you. Probably not. Is there an underlying third factor I haven't identified, like the economy or something? I don't know. But the point of these slides is that correlation does not equal causation. Is this the post hoc fallacy, I believe? Post hoc ergo, is that? I think it might be post hoc ergo propter hoc, after it, therefore because of it.
There was a website dedicated to this, I seem to remember seeing, and there was one, the number of libraries in a state in America correlated perfectly to gun crime in that same state.
Yeah, there is. So yeah, there is a whole, there's actually many websites dedicated to these. Now, the chances are that this is a coincidence. But yes, there are also, the famous one is the one that the Church of the Flying Spaghetti Monster came up with many years ago, I think back in the 90s or something. And that was that there is an inverse relationship between average global temperature and the number of pirates. And if we were to treat that as a causal relationship, we should all become pirates to prevent global warming. I suspect that that may not be the case. So anyway, the point is, be careful. Just because you found correlation, what I have found with my limited dabbling into this is that when you are looking at the data, you still, as a human being, need to be able to eyeball the problem and see the problem yourself and understand why you are seeing these relationships in the data before then you go to the next step, which is crunching the numbers and coming up with programs that deal with this. So let's try and improve on our Pokemon calculation. I'm going to do multiple linear regression, which is same basic concept, but what I'm going to do is have multiple data sets. Rather than simply like to wait, let's have a load of things. See if I get a better result. And this is going to mean talking about matrices. Now, this is not like this film, which, yes, I have seen, of course I've seen. I think they just thought the word matrix sounded cool and used it in their film. A matrix, if probably most of you might know, is just a table. It's just a table of data. That's an Excel spreadsheet is a matrix. It has nothing to do with dressing like this. It's a bit like the film Source Code. Has anyone seen the film Source Code? What has that got to do with source code? I have no idea. They just thought it sounded good.
What's stopping you coding in Excel like that?
What's stopping me coding in Excel like that? How do you know I don't? Every day before I start Excel, I get on my glasses, on my storm jacket, and now I am ready to begin. Yeah, if I can have Carrie Ann Moss to help me, I will not object. So, To give you an idea, I've got to do some matrix multiplication. A matrix multiplication is just a shorthand for a whole load of sums. So just briefly, this is how it works. You get two matrices. I've tried to use some colors to make it clearer what I'm doing. I've got matrix 1 and matrix 2 here, which I have used the square bracket notation to denote. I've put coordinates around them just so you can see which bit I am talking about. So the new matrix, which is the result of multiplying these two, is equal to the number of rows of the first one and then the number of columns of the second. The order at which you put them is significant. Unlike normal multiplication, where you can put it either way around, with matrix multiplication, you cannot. The order is important. And what you do to calculate, for example, the top left-hand item there, you take XA multiplied by AX plus XB, that is going along the rows and along the first one and the columns of the second one, take each pair of values and multiply them together, and then add all of those multiplication factors together, and then you've got the new row. So in my case, the top left is 75 because it's 1 multiplied by 1 plus 2 multiplied by 1 plus 4 multiplied by 2 plus 5 multiplied by 3 plus 7 multiplied by 7. Matrix multiplication is a simple way of saying all that. There you go, and that's the entire. I just made up those numbers, but that is what the matrix multiplication of that would be. Okay. As it happens, Excel has got all of this stuff built in. I did say Excel was weirdly useful for this stuff. And there are 3 matrix operations I'm going to use. mmult, which is a matrix multiplication, and you just literally do 2 selectors, and it treats them as matrices, and then you get yourself your result. Great. Transpose, which means take the rows, turn them into columns, the columns turn them into rows. Flick it round. And inverse, oh dear God, inverse. Inverse is the equivalent to turning x into 1 over x in normal mathematics. I am not even going to go close to how you do that because it's horrible. I thought about it and I spent an evening working out how I'd explain it. Just no. Excel does it. It's M inverse. Just use that. Trust me, it's not nice. So here is the process. 2 matrices. We've got our y. The y is the thing we're trying to calculate ultimately in our training data set. And we have 3 columns that I'm going to use because they're the ones that had a decent correlation. Height, the number of steps required to hatch an egg, and the defense. Those were the 3 best correlating columns to weight. And you also have to put a random column of 1s at the beginning. So you've got the 1s, then each of your data item columns, and a single column of the y's. Right, what do we do? First, transpose your x's. Then multiply that by the original set of x's. Then inverse it. Then multiply that by the original inverse column. Then multiply that by the y column. Yeah, I know, it's a bit like solving a Rubik's Cube, isn't it? But nevertheless, the point is, and if you could do all of this, by the way, quite easily in just a couple of Excel commands, what you get finally out of all of this rubbish is a matrix which has a single column and a row for the intercept and then a row for each of the x's. And this is basically the equation. There it is. So the intercept is minus 70.5. X1, that's height, is multiplied by 48.449. Egg steps is multiplied by 0.003. And hit points is multiplied by 0.7. There you go. That is my linear equation, which uses now 3 data items in order to make my final calculation. So, is it any better? 47.26 is my R, which is better. So I've gone from 39.7% fitness for purpose to 47.26%, significantly better. And you get the idea. I could probably plug a whole load of other data items in there, although do not be tempted to just stick all of them in there, because sometimes some data is actually misleading and will reduce your accuracy because it's really not related. So you're better off just looking for the strong hits in correlation and sticking with those. So now logistic regression. So I've talked about linear regression. Linear regression was about mapping a continuous data column to another continuous, basically mapping one unit of data into another unit. And now I am going to talk about logistic. Now, logistic regression is about, is something true or not? Does this fit this category or not? Effectively, it's going to give us a Boolean. A Boolean, or rather, it's actually going to give us a decimal. But the decimal is the probability that a given idea is true. So I am going to do it with Is this Pokemon a legendary, like this gigantic Dialga on the left, or is it not a legendary, like the slightly annoying Pikachu on the right? And I am currently imagining how interesting this will be if the Dialga carries on walking. But there we go. Right, correlations. What correlates to being a legendary? Well, obviously being a legendary does, but once again, that's useless. Base egg steps, 87%. Base happiness, minus 41%. Being a legendary means being slightly less happy. Oh, oh, poor thing. Maybe it's because they're so rare and they're lonely. Poor things. I'm sure what will cheer them up is me chucking a ball at them and locking them in that ball and then forcing them to take part in underground fighting matches. That usually cheers me up. Of course, I'm not the one fighting. That's why. Capture rate, minus 33% correlation. Makes sense. They're harder to catch. Yeah, sure. There's a 33% correlation with how much experience required to make them grow. Makes sense. 31% correlation with hit points. So they have more hit points. Makes sense. All of this, to be honest, there's a load of data correlations. The attack is better. The defense is slightly better, but not as much as the attack. Weight is heavier. They tend to be bigger and stompier. Not all of them. There's some really little legendaries, but most of them are pretty big and pretty stompy. The best ones, I think, are base egg steps, base happiness, capture rate, special attack, and weight. And I'm going to use all of those to determine, given this Pokemon, is this Pokemon a legendary? And it's roughly the same step. First off, we're going to calculate the logistic equation. This is a logistic regression. Sorry, a linear regression. This is the linear regression. So that's just as before, but there's an extra step to make it a logistic. Take the exponent of is it a legendary, divide by 1 minus exponent of is it legendary. That is calculated by this. Exponent is raising it to the power of 2.71828, and so on. There's a lot more numbers, but you get the idea. It's one of those magic maths numbers. And what this gives us is a set of probabilities. The first column is the actual answer. Y is 0 means it's not, 1 means it is. The second is the linear regression answer, and the final is the logistic answer regression. So what I notice is that more often than not, most of this is hovering somewhere around 0.5, give or take a little bit. But if I have a look at the ones, wherever there's a 1, we go up from about 0.5 something to about 0.6 something. So for some reason, it thinks everything pretty much is about a half-half chance. But when we're actually looking at a legendary, it thinks it's not 50-50, it's more like 60-40. So I have used about 0.6 as my cutoff to say, if logistic regression thinks there's about at least a 60% chance that this is a legendary, I'll treat it as truth. And this is my results. So I have true positive result, 63. That is, I thought it was, 63. False negative, I thought it wasn't, but it was, 7. True negative, I thought it wasn't, and it wasn't, 729. False positive, I thought it wasn't, and no, I thought it was, and it wasn't. So that means that I got 9 wrong. 9 wrong out of about 800. So that is a 98.88% accuracy. And that's pretty good. In all honesty, it's pretty good. There's probably ways of refining that further and getting even better. But, you know, I'll still stick with that. That's machine learning terms, that's pretty good. So moving on to naive Bayes, that's my next algorithm. And I'm going to use one of my very favorite things in all the world. That is, of course, Doctor Who. So I've collected some statistics here for a whole load of stories of the various doctors that have been over the years, since the boss himself, William Hartnell, all the way up to Ncuti Gatwa, who sadly slightly underrepresented in here because he's only had 1 story to date. This slide may need to be updated in about a month. But for now, he's only had 1 story. And the Daleks are, of course, the most popular monster in the whole of Doctor Who. And given the first column is how many stories overall that Doctor had, and I know that how many stories a Doctor had is problematic at best. But these are the numbers that I've chosen. I don't know whether there's any serious fans in here, but I'm treating Trial of a Time Lord as 1. Okay, any Doctor Who fan? I'm getting blank looks, so there's clearly no Doctor Who fans in the room today. Sorry? It's 4 stories, but I'm treating it as 1. I went with what is actually the official BBC statistics, and they treat it as one. Strictly speaking, it's written by 4 different writers, 4 different production teams, but it has 14 episodes all with the same title. But if we're going to go down that route, then is Mission into the Unknown at Galaxy 4 Part 5, or is it its own story? Once again, you could argue both ways. There's how many Doctor Who stories have there been is so ridiculously complicated, only people like me care about it. Yeah. Sorry? Let's argue about this later.
How many, the bell curve of bubble wrap, does it really appear more in the middle where when it's
Oh, the bell curve of how much bubble wrap. Oh, that is a good one, because there is at least one embarrassing monster in Ark in Space, which is indeed a man in green bubble wrap, crawling around going, "I'm a monster." He doesn't actually say "I'm a monster," but I really wish he had. Yeah, I mean, in fairness to that particular story, bubble wrap was not common at the time, and no one would probably have recognized it. Now it is painfully obvious and quite funny. Right, anyway. So the first row is how many stories did this Doctor have? No arguments. It's just the numbers I've gone with. And the second is how many Dalek stories did that Doctor have? And I am treating these only as where they're the main baddie and not just strolling around in the background somewhere. Okay, so William Hartnell had 5, Patrick Troughton had 2, poor old Paul McGann had 0, but that's not hard because he only had 2 stories, and so on and so forth. So if I were, I could put some probabilities now that given this Doctor, I have a fair chance of what's the probability that if I have a bag of, say, all William Hartnell stories, and I just pulled one out of the bag, I would know what's the chances there's Daleks in it. It's like 5 in 29. And there you go, there's your probabilities. So it's a 17% probability that given a random William Hartnell story, which is more complicated because like loads of them are missing, but I can't stop. And so on and so forth. But there you go. But there is another way of regrouping this data. This is what Naive Bayes is about. It's basically a bit like using a group by in Link. We are currently grouped by Doctor, but we can take all of this data, and then do a group by and a resort, so we have regrouped by Daleks. That is, given Daleks, what's the probability of William Hartnell? So then I switched to having a bag of, so from a bag of all William Hartnell stories and dragging one out to see how many, if it's a Dalek or not, I can take the whole set, reshuffle it, and now I can say, given a bag of all Dalek stories, what's the chances William Hartnell's coming out of the bag? More useful than you might think. This is the equation. The probability of A given B, that is, Daleks given Doctor, is equal to the probability of B given A, that is, Doctor given Daleks multiplied by, no, it's the other way around, but you get the idea. So take each of those probabilities and multiply it by the probability of A occurring divided by the probability of B. And this is what you get. We get slightly different statistics. So now, in my imaginary bag of all Dalek stories on DVD, there's a 17% chance that William Hartnell's going to pop out the bag, which is actually not all that different. And there's 1 or 2 that are different. We're now seeing a lot less chance of John Pertwee. He's gone from 17% down to 13% out of the big Dalek bag. And Jodie Whittaker has jumped to 17%. So yeah, okay, that is a regrouped. But there are other ways of using this. There are, for example, for a start, this is actually how a spam filter works. It uses, but it does not use, of course, nonsense like Doctors and Daleks. It uses observations. It uses observations like certain words, certain statistics. And still, you can, as long as you can assign a probability to it and you can assign a category to it, you can use Naive Bayes to work out what's the chances that, given this new data, what are the chances that this belongs to the category or not? So an example of how you might use this, I have picked out 2 of my favorite books. A Journey to the Center of the Earth by Jules Verne and The War of the Worlds by H.G. Wells. I am using an English translation of Journey to the Center of the Earth because, of course, it was written in French. And it would be too easy if I just left it in French. So I want to use a classifier. That is, given a random sentence from one of those books, how can I determine which book it belongs to? I can, using Naive Bayes. So first step, remove all of the noise. Reduce right down to just get all the lines. Remove the stop words. That is, Words that are so ridiculously common that statistically they are meaningless. Words like I, me, myself, we, our, ourselves. These words tell me nothing because practically much every book in the world will contain them, in English, that is. Remove punctuation, remove one-word lines because I can't tell you anything from one word, unless maybe it's the word Martian. I suppose that's what you get giveaway. But that's a very strange sentence. And then remove numerical words. This was a step I had to add in at the end of this process because, of course, numbers tell me nothing. They're not words, but it's a number. So what can I say about that? Okay. So I'm going to take each line of each book. So I'm going by lines. I got these texts from Project Gutenberg, which is the online repository of all public domain texts. These have been public domain for, as you know, that's not true. H.G. Wells has only been public domain for a few years, but they've been public. Otherwise, they are available freely online. Great. So let's run this through Naive Bayes. Let's first start with the first word. Now, given only one word, I do not know what the probability is of this word existing in one book or the other. So I'm going to have to make an assumption at this point that it's just 50-50. And I'm also going to make an assumption that there are no more books in all of the universe for the purposes of these calculations. Otherwise, none of it works. But that's good enough for the purposes of this classification exercise. So the probability of the word one, given that it's War of the Worlds, is 0.0062. That is, given all the words in War of the Worlds, that's the chance that one is in there. The given journey, it's 0.00495. So the probability of the word is add these together. Because for the purposes of this exercise, I'm assuming that these are the only two books. So that means if I run it through Naive Bayes and the probability of it being Journey to the Center of the Earth at all is impossible to determine at this point, so I'm going to assume 0.5. Now, Naive Bayes works by determining what's the probability that this belongs to this category, just a single category. So I can't say which does it belong to. All I can say is what's the probability it's this one, or what's the probability it's this one. And then I'm going to do both of those and work out which is the highest at the end. And that's my answer. So the probability, given the word one, that it is in War of the Worlds is the probability of being War of the Worlds at all. The probability of the word given War of the Worlds multiplied by 0.5, because that's my assumption for the first word. And can I move this? No, it's not going to move. There we go. Fine, okay. But run all of that, and what you get is the probability that it is War of the Worlds is 0.278. And the probability that it is Word Journey is 0.22156. So this is indeed the rather famous first sentence of War of the Worlds. No one would have believed in the last years of the 19th century that blah, 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 blah. If you've ever heard the Jeff Wayne album, then you know the line. So actually, straight off the bat, it's already saying that War of the Worlds is a bit more likely. And what I can do then is iteratively apply this process again and again to each word, but this time switching my probability of one or the other from simply 0.5 to the current probabilities calculated by the previous step. There's actually a mistake there, but there we go. And as we apply each word one after the other, we can update our probabilities of either it's this book or this book based on the previous answer. And what we should have is a result which, as we add each word in, becomes more and more refined with time, and we eventually get a more secure answer. And the curve actually looks like this. What you see is an initial bit of weirdness because we don't have enough observations to be able to make a definite choice. But as more words are added in, the X column there is how many words. By the time we got to 7, we pretty much have pretty consistently got War of the Worlds on the top. So we've identified correctly that the book is War of the Worlds. And I can't remember what my actual overall statistics for how accuracy were, but they were up in the 80 to 90% accurate. It's very accurate, at least with War of the Worlds. So K nearest neighbor, penultimate algorithm now. K nearest neighbor works by treating everything as numbers and then working out the Euclidean distance between them. So the Euclidean distance being like, Pythagoras, basically. Start here, work out what the exact shortest distance is given this to this. That's what that is. And then you work that out for the new data point, treating all data points as axes, X, Y, Z, and so on. And then work out what is the nearest in actual space, as if we could work out the actual space distance between them. Then you pick the top however many you want to pick, and then whatever the consensus of opinion about the category that you're trying to assign within that set of neighbors is the one that you're going to choose. I don't know with color. Color is a nice continuous variable. So color is interesting because we treat it as categorical, and yet it's not. It is entirely linear. In fact, it's possibly four linear values. So I have picked a random color, literally random. I just went to random.org, and I got the RGB of 221 red, 45 green, and 65 blue. And that looks red to me. So what I'm going to do then is I also got a data set of loads of categorized colors with names like gray, slate gray 4, and so on, with their RGB, and then literally calculated the Euclidean distance between my new color and every single color in the entire set, and then ordered them by their distance in descending order, ascending order, and picked about the top 5, I think. And then whatever the majority in that top 5 was, that's obviously what we are. So to work out this distance, as I say, it's just Pythagoras. So take the square root of the difference between A and B plus and so on and so forth. There is your equation. And for example, gray there, 84, 84, 84, you work out the difference between each of its RGBs, and each of the RGBs are my one, and then square each of those, and then take the square root of the whole set. And I end up with a Euclidean distance of 143.7 between gray with 84, 84, 84, and this one. These are the closest 5 neighbors when I do the whole set. And it turns out that my color is in fact brown. Okay, fine, I suppose. Maybe my monitor's not very good, I don't know, but fine, that's what the nearest neighbor says. So fine. Now, the downside of this method is that you have to just calculate the Euclidean distance between your new data item and all existing data items. If you've got thousands of them, you're in for an interesting time. If you've only got a few hundred, then that's not too bad. So the last one before we finish up is decision tree. Now, decision trees are ridiculously complicated. In some ways, actually, one of the most powerful ones, but they are ridiculously complicated. I did think about doing a worked example of the entire process of making a decision tree. It is so complicated that honestly, it would take this entire lecture. So instead, I'm just going to give you an idea of how they work. If you're interested, you can look it up, but there is a lot involved, especially once you start talking about pruning and optimizing. It just gets more complicated. ML.NET does all this rubbish for you. Just tell ML.NET my data is here. It will give you a decision tree that works fine. So I am going to describe how a decision tree works by the aid of some friends. Now, does anybody not recognize these individuals? Because certainly I spent an awful lot of my childhood playing with them. This is the figures in Guess Who, the 1990s edition I grew up with. Is everybody familiar with the rules of Guess Who? Is there anybody for whom I need to describe the rules of Guess Who? Do not be shy. I know it's not as popular as it used to be. Okay, I am now going, no, that's fine, that's fine. Then I shall explain the rules of Guess Who. Right, so you and your friend, or relative in my case, relative / brother, have a set of a sort of a table thing each with a load of cards standing up like this, each of which has faces on. We have an identical set. He has all the same faces I do. I say he because I played my brother. We each have a card which corresponds to one of the faces, which we put face up facing ourselves. That is our face. Each of you may ask only questions which will result in either yes or no. And based on and they are questions about your person. I mean, you can ask other questions if you like, but they're not relevant to the game. But if whatever they say, based on the characteristics that the person that they has or hasn't got, you flip down all the ones that no longer match. Okay. So I could, for example, say, is your person male? If they say yes, I will flick all the ladies down. If they say no, I'll flip all the men down. Are we clear? Eventually, the objective is to work out which person they have without having seen it. The advanced versions have 2 cards at the same time, and that version's tricky. You can only say, do either of your people have? That's the advanced version. Anyway, I digress. So the optimum way to win at Guess Who, in as much as there is any sort of a method to, is to try and make sure that whatever you guess each time it will result in about 50% of the people being dropped. I could go with a low probability thing, like, for example, there are only a couple of people with blue eyes. If they say yes, well, I pretty much won this game then. If they say no, I've achieved very little. So the best method is to try and remove 50% of the people each time. Because whatever they say, I am reducing 50% of the number of standing up cards. And then you're going to have to come up with a new question based on what's left. You don't just have a whole big bag of 50% reduced questions. Based on whatever they said yes or no, you've now got to formulate a different question. Let me show you. So first off, is there actually any characteristic here that will allow you to remove 50% of the people? Sorry?
Gender.
No, it's not. And it's absolutely not. And I don't think that's by reason of sexism. I think it's because otherwise the game is unbalanced. Because if there was an easy way to remove 50% of the people every time, well, that's always going to be a first question. So hair color. Now, bear in mind, there are how many people here? 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8, anybody? Thank you. I'm terrible at arithmetic. 24 people. So hair color. 5, 5, 5, 4, 5. No, useless. Gender. There you go. 19 males to 5 females. Once again, I don't believe that's through sexism. I think it's trying to maintain game balance. They're trying to make sure that there's no statistic which is shared by more than about 5 or 6 people. So how about the rest of it? Facial hair, 7. Eye color blue, 5. Rosy cheeks, I tried ridiculous numbers of things, 5. Big nose, 6. Glasses, 5. Hat, 4. So short answer, no. So the only way to make a first move is a compound question, which is a great way to make my brother hate me. Does your person have a hat or glasses or jewelry or earrings or a bow? If any of those things are true, then I'm going to flick down 11. If none of those things are true, then I'm going to flick down 13. I couldn't find a precisely 50-50. If there is one, I would love to hear about it. I'll update the slides that day, but I haven't found it yet. And I really did try. There is no lengths that I will not go to. Female or facial hair, 13 or 11. Hat or glasses or blue eyes, 13 or 11. So either of these is not bad. So I'm going to play a game of guess who. Who is my person then? I am going to say female or facial hair. Yes or no. Sorry, those are slow notes. It is a yes. My person is female. Okay. So I've eliminated a whole load of people from my inquiry. So now what I have to do is find, with all these people who are remaining, how do I remove 50% of these guys? We have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 people. Well, we're not going to get a 50-50, but what can we do? I'm going to go with beard or blue eyes. Yes, 6 or no 7. So again, I don't really care which one you're going to check. It's no. No beard, no blue eyes. Okay. There we go. Eliminated another load of people. And as you can see, 2 turns. And I've already eliminated most of the people on the board. I'm a long way towards winning. My brother's probably still wondering whether I'm wearing a hat or not. So I want to eliminate another 50% based on the however many it is, something like 6 people who are left. Black hair. We've got a few enough people now that there are statistics which are going to stand out. Yes, 3, no 4. Once again, don't care which. No. So the black hair is yes, there's only 3 people left. Something like that. There's 4 people left. Okay. Yes. Next. Hat. Because there are only 2 people left with a hat. Notice, there we go. So it's 2 and 2. They do have a hat. So that means it's only Claire or Maria left. Notice I've effectively whittled it down to a lady, even though I never exactly asked that question, not openly. So as it happens, you may as well, now that you're 50-50, you may as well just ask, is it Maria? Yeah. Because honestly, I always thought Maria looked so cool. I mean, she does look at it. She's awesome. So that's it. That is an example of how a decision tree works. Now, it's not going to be literally yes and no questions. More often than not, it's going to be sort of deciding in a linear data set what's the cutoff. That's going to be a lot of it's going to come in. And it's going to be a predetermined answer. When they calculate the decision tree, it's going to have a predetermined tree for every possible yes or no answer. And you're basically like one of those marbles, just go until you get an answer at the end. This is the algorithm that I used when I worked on Kaggle's Titanic Challenge. Now, the Titanic Challenge is one where you have a data set which is all about each passenger who was on the Titanic, and you have to make a decision, true or false, they survived or they did not. And a binary tree algorithm is what I use for that exact purpose. And that's an entire other talk all by itself, but it was using various bits of data and some optimizations and a lot of other stuff too. But you get the idea of roughly the principle of a binary, of a decision tree. So further reading. This book is very good. I enjoyed this book a great deal. Statistics by Witte and Witte, or Witt and Witt. I'm actually not sure. I speak German, so my inclination is to say Witte. But this is a great book. This is generally on statistics. If you want to get into data science, my understanding is the best way is to start with statistics and then move on to other books. I have also been recommended this by a professional data scientist who said it was a good book. And I've had a look, and it does indeed look like a good book. It's a Python book, though. This one is a maths book. This one is Python. So as long as you're happy with Python, you have no problem. It's also available for free at the link at the bottom. Free is my favorite price. And also this book, the 100-page machine learning book. I based a lot of the algorithms I picked up in this talk on this. This is also available for free at the link at the bottom of the page. Free, as I've said, is a good price. I own a physical copy because I like to read it in bed, because that's normal, isn't it? So, go on. Aegarti punthaneton aite ermeneuton. My ancient Greek is not great. I'm working on it. That is, does anybody have any questions?
Very good first.
Thank you.
I don't see anything from the chat because that number 3 hasn't changed since last time.
Fair enough. They're in awe of me.
Quick question, go check what the name of that 100 or something machine learning.
Yeah. The 100-page machine learning book by, I think that's pronounced Andrei Burkov. I am not 100% sure, but it's on themlbook.com for free. Also, the book is not 100 pages long. I checked. But fine, it's slightly more than 100 pages. I will accept that. Bonus content, I suppose. It's a very good book, and he does a great job of giving a language-neutral, easy, approachable description of how the machine learning process works. I like this book quite a lot. I do dip into it on a regular basis. Okay. Any further questions? So,
in the horrible way, comment, not a question.
oh,
Does their name contain 2 vowels? Is the 15 lines?
so if the does the name contain vowels? Does that have 2 vowels? Okay, I'm not going to sit here and count tonight, but watch this space. Keep an eye on Twitter. I will check. Oh, yeah, but then everyone at home just going to be saying, why is everyone just staring at the screen and going, yeah, that's a really good one. I like that. Does the name contain 2 vowels? We'll have to see whether that does give you a 50-50 split, in which case that will be. Yeah, it's still not a bad one. That is closer than any single question I've ever managed to come up with. Compound questions is the only way I ever managed to make that thing work at all. But I like that. There might well be a hidden data item somewhere in there, but I'm not sure what it is. I mean, maybe I'm reading too much into a silly kids game from the 1990s. That's entirely possible. But I don't think that's the case, because everything should be taken this seriously. Oh, I forgot to say, by the way, since you were the first person to ask a question over there, you can have a copy of my book if you like. There you go.
Thank you very much.
Sorry, I forgot to do that earlier. Sorry, chap. I only have the one. But I did mean to hand that out to the first person to ask a question. It's a C# book. Are you a C# developer? Oh, there we go. That's maybe not the first book to read, although it is probably the silliest book you can read. Although I used to think it was probably the silliest computing book ever, but then Dylan Beattie told me about some Mr. Bunny's Big Cup of Java or something like that, which actually is the silliest computer book ever written. But mine's the first to feature Amitabh Bachchan, the Bollywood legendary actor, in the index.
I got the first word.
Yeah, literally, Pete. Literally, Pete is the first word in that book, or rather, Pete's words are followed by Pete's name.
The first.
Oh, excellent! Yeah.
Peter provided what's called a praise quote for me. He read it and then did not die and felt that he did learn enough from the experience to provide a quote for the front.
I wasn't worried about dying. My eyes falling out, maybe.
That's
It's always like,
Is that your quote? Did not die.
did not die, eyes intact. Yeah.
nice. I actually wanted, and I tried hard, to get a really famous person to give a quote who's not computing, like Tom Cruise or something, to say like, "Hey, what is this?" And that would have been, it would only have worked if it was genuine, but I couldn't find anyone famous enough.
Who are you? Get off my lawn.
Yeah, that's exactly who are you? Get off my lawn. That's exactly the sort of quote I've done. Wouldn't that have been funny? No, I'm sorry, who are you again? Something like that. But no, I went to the .NET Rocks guys, and one of them, at least we came up with a vaguely funny quote together. So you can read and find out what it is for yourself. But yeah, I had
If
fun
you do
doing
that
it.
in the future.
Oh, who do you know?
I work for QI, so I've been in contact with.
Oh dear God, if only I'd known. Next time I'm writing a book, I am totally going to see if we can get somebody. And it would have to be just something something like I said, stupid, like, hey, what? Or, you know, like so utterly out of place. But that's my sense of humor. Right. Does anyone else have any further questions?
Have a probability of one.
I had a probability of 1 on one of them. I'm not sure. I'll have a look later. I will go and double check over all of the numbers and make sure they all line up. The actual calculations were right as far as I can tell, but some of my copying and pasting into PowerPoint may have failed here or there, or possibly some of the screenshots might have like been. I'll check it though. But thank you. So.
On the subject.
Oh God. Oh God. I'm just going to go and hide down here.
In your logarithmic question,
Mhm.
you said that the exponent was x to the power of b, t to the power of x.
It's about X, and darn it, I just used Excel, and Excel just made the answer come out. This might make me a bad person, but I would like to argue that maths is incredible, and those people who can do theoretical maths are amazing. I just use it, and I don't need to understand it to that level. Although you need to understand in theory what it's doing, but some of those algorithms you come up with, I just use them. That's what you read. And actually, most data scientists, I suspect, don't even do what I've done, and that's actually go down to first principles. Mostly, I would imagine you go into Python. Python's got a library that just says, make a decision tree. Bang, decision tree. That's largely what most people do. But I like to make sure I understand in principle what I'm doing, because that makes it easy to know when is it right, when is it not right, which algorithms are best suited to which purposes, what is the algorithm doing, this result looks strange, why is that strange, well, let's have a think about what it's doing behind this, you know, that sort of thing. And that's why I go down to first principles, not because I'm planning to do it necessarily, although you can. But
History using a lot of to get those first principles.
yeah, you need a lot of background knowledge. Yes, I mean, each one of these slides could nearly be a talk in and of itself. I mean, this is a massive subject. People base their entire careers out of data science. People have, I even know 1 or 2 people have PhDs in data science. It is a colossal subject. And I'm just puttering around with it, but the results, even at my level, even at my rather crude, primitive level, are still, I think, fairly reasonable. And the other nice thing about things like logistic regression and the like is once you've done the calculation, you can just store those raw numbers, and it is just about one of the most efficient calculations you can do from that point on. The hard bit is the training. Once the training's over, your result is incredibly efficient. I mean, effectively, a decision tree is more like it's like a binary chop search algorithm, isn't it? So it's very fast and very efficient. It's just the training, and that's where most of the work comes in: is how do you train, what do you train, and then we get into the tricky area of hyper optimization of parameters, and then it just gets very complicated very fast.
I'll
So
also throw in, and taking you back to university, inverting a matrix.
inverting a
When you get
matrix.
a very, very large matrix, it starts to matter which algorithm you use. And if you use a very precise one, it can take thousands of years to run.
Oh,
And if you take an imprecise one, then an engineer might go, yeah, or might go,
Right.
and the numbers come out all skewy.
okay. So based on which algorithm you use to calculate an inverse matrix, the calculation with large data sets can potentially take a long time if you make the wrong choice. I used Excel. And Excel gave me an answer, and I trust that Excel knows what Excel is doing, which is not a thing I ever thought I'd catch myself saying, but I did. So I'm sure that you're right, but I just use Excel. I'd be surprised if there's not a library in C# available. There's certainly one in Python. I would put money, and I don't think I'd lose my money if there's one in Python, because Python is the playground for all the data scientists and mathematicians and so on. So machine.
Double check. I think.
I know there's one in Fortran on my
There's
memory.
one
I think.
Of course, there's one in Fortran.
But they're not memory.
The problem is no other bugger uses it.
Fortran 77.
If you multiply a matrix by its inverse, you get both density.
Which is like what? It's a line of ones. Yeah, it's a sort of matrix equivalent of 1.
Yeah.
Yeah. So that's the way I understand it in my head. But again, I did the calculation for a 2x2 matrix inversing is not all that hard. But as soon as you go beyond a 2x2, it's nasty. It's really nasty. And why do I need to care when I just want to do it? You know, that's why I didn't bother to go beyond what I did in here, because look it up if you're interested. I'm not. If you still live at the end of your explorations, tell me about it. Does anyone else have any further questions? Okay, well, beyond that, okay, if anyone is interested, this is my GitHub page where I've got all of the code that I used in this. A lot of it's in C#. The classifier for the books is C#. A few of the other classifiers are C#. A lot of the linear regressions and things are Excel. They're not there.
Oh,
no, go on.
Chat questions there.
Oh, there's a chat question.
Well, there's 2 things. It might just be thank yous, but
Never know. I hope they are. Oh, 6. Oh, God. Hide, everyone, run.
No problem, we'll get chucked out anyway.
Is it the security guard downstairs saying, he's still up there?
Yeah.
Connell says only 5 Guess Who characters have only 1 vowel or less.
Sorry, chap.
Oh,
I said 2, there was someone 3.
yeah.
Okay.
Well,
Thank you.
It's a different way of thinking.
Yeah, thank you for checking that for us, though.
These were thank yous.
Oh, that's very nice of you. Thank
Yes.
you.
16 with exactly 2, Colin.
Oh, okay. Okay, this is my website where I have articles which go into more detail about some of these processes. I'm still in the process of writing a few of them up, but there's a lot more about things like the naive Bayes classifier and a few others if anyone is interested. And then beyond that, there is my book again. Once again, this gives you a free month on O'Reilly if anyone wants it, where you can read many books, including mine, hint, hint.
Have you started making profit on that book yet? Are you allowed to tell me that?
I do make profit. I mean, it's not much. I mean,
It takes a while, doesn't it? Don't we have to sell a certain number first before you?
No, they send me royalties each month. On most of it's from the online platform. I get views every time. I get money every time someone views it.
Cool.
So if you would like to read my book on the online platform, I'm just saying I could do with a new pair of shoes. But it doesn't make very much money. You don't go into the book writing business to make money, in all honesty. And this will answer the remainder of your questions if you have any. But thank you very much.
Thank you. And with
By induction. By induction.
I was such a geek at school, I nearly got into a lot of trouble actually, that I programmed my programmable calculator. Bear in mind, I'm not young, so this is just when programmable calculators came out, to do matrix multiplication, because I knew it would come up in the exam. Only I made the mistake of telling one of my friends who then snitched me. But the lecturer took us all in, and he said, did you program the calculator to do that? Yes. Did you have to understand exactly how to do matrix multiplication to do that? Yes. Good. Well done. Bye.
Love it.
He loved it. And that's
Love it.
engineering, isn't it?
It is.
The way to do it.
I got drop on my maths exam for very different reasons. I thought it'd be very funny if I took a mechanical pinwheel calculator into my.
I'm not surprised with you either. That's awesome. Brilliant. Jeez.
It once and they took it away and gave me a normal calculator.
Yeah, we would have allowed you to use it. It's just too noisy. Right, folks. With that, I'll stop sharing and say goodbye. We will be back on the 3rd of June, hopefully with Cliff Aegis, if not somebody else. Put your hand up. By all means, we welcome speakers. Onwards from that, we'll catch you again soon. Thanks very much for coming. Bye.
So Connell's got real Guinness. I'm jealous.
Ah,
Ah,
nice.
Swine.
Uh,
Swine, you are.
See you later. Thanks, Connell.